AMD 135 is the company's first small language model, targets speculative decoding for technological progress. AMD has unveiled its first small language model, AMD 135M, which utilizes speculative decoding to leverage AI capabilities, ultimately leading to an enhanced technology process. AMD decides to jump into the AI model bandwagon, reveals a small large language model that is more efficient at token generation. In the ever-evolving landscape of artificial intelligence, large language models, LLMs, like GPT-4 and Llama have garnered significant attention for their impressive capabilities in natural language processing and generation. However, small language models, SLMs, are emerging as an essential counterpart in the AI model community, offering a unique advantage for specific use cases. AMD is excited to release its very first small language model, AMD 135M, with speculative decoding. This work demonstrates the commitment to an open approach to AI, which will lead to more inclusive, ethical, and innovative technological progress, helping ensure that its benefits are more widely shared, and its challenges more collaboratively addressed. AMD 135M, first AMD small language model. AMD 135M is the first small language model for Llama family that was trained from scratch on AMD Instinct MI250 accelerators utilizing 670B tokens and divided into two models, AMD Llama 135M and AMD Llama 135M code. Pre-training. The AMD Llama 135M model was trained from scratch with 670 billion tokens of general data over 6 days using 4 MI250 nodes. Code fine-tuning. The AMD Llama 135M code variant was fine-tuned with an additional 20 billion tokens of code data, taking 4 days on the same hardware. The training code, dataset, and weights for this model are open sourced so that developers can reproduce the model and help train other SLMs and LLMs. Optimization. With speculative decoding, large language models typically use an autoregressive approach for inference. However, a major limitation of this approach is that each forward pass can only generate a single token, resulting in low memory access efficiency and affecting overall inference speed. The advent of speculative decoding has solved this problem. The basic principle involves using a small draft model to generate a set of candidate tokens, which are then verified by the larger target model. This approach allows each forward pass to generate multiple tokens without compromising performance, thereby significantly reducing memory access consumption, and enabling several orders of magnitude speed improvements. Inference performance acceleration. Using AMD Llama 135M code as a draft model for code Llama 7B, we tested the inference performance with and without speculative decoding on the MI250 accelerator for data center, and Ryzen MI processor, with NPU, for IPC. For the particular configurations that we tested using AMD Llama 135M code as the draft model, we saw a speed up on the Instinct MI250 accelerator, Ryzen I CPU 2, and on Ryzen I NPU 2, versus the inference without speculative decoding. 3. The AMD 135M SLM establishes an end-to-end workflow, encompassing both training and inferencing, on select AMD platforms.